This is the lesson for Chapter 1, Section 3, titled Real Numbers in the Number Line. Let's take a look at our first problem here. And here we're taking the square root of 36, finding two numbers that multiply to make 36, and 6 times 6 makes 36. That's the number that we're going to end up going with there. Here we've got an odd number, 121, and the two numbers that multiply to make 121 are 11 and 11. When I'm looking at 225, it's a little bit bigger number, so what I'm going to look at are some benchmarks. I know that the square root of 100 is 10, the square root of 400 is 20. So I know it's in between those two numbers. And since it's an odd number that ends in 5, I'm going to go with 15. That is the answer. Here we have the square root of 225 over 169. So we're going to treat this as two separate radicals, and we're going to take the square roots separately. So 15 over 13 would be our answer for this one. On this one, we've got a square root that has a decimal in it. Well, that means our answer is going to have a decimal as well. Two numbers that make 81 are 9 and 9, and to make 0.81, I'd have to do 0.9 times 0.9. Taking a look at the next type of problem here, it says to estimate the square root round to the nearest integer. So what I do is I look for the square roots that it's between. So I've got the square root of 9, and I've got the square root of 10, the square root of 11, the square root of 12, the square root of 13, the square root of 14, 15, and 16. So 9 and 16 are the perfect squares. So the square root of 9 is 3, the square root of 16 is 4. So I know these answers, the answers to these square roots are between those, and I look to see which one's closer. So you see how 10 is closer to 3, or is closer to 9, so that means the answer is going to be closer to 3. So 3 would be a good answer since we have to round to the nearest integer. Square root of 50, well, I look at the perfect squares that 50 is between, and those square roots are 49 and 64. The square root of 49 is 7, the square root of 64 is 8, so I would go with 7. Here it says to find the approximate side length of each square, and we're going to round to the nearest whole unit. So we've got an area of 64, and since it's a square, we can take a square root. And so the square root of this is just going to be 8 feet. And on this next one, we take the square root, and it looks like a tough number, but if I look at some perfect squares, some benchmarks again, the square root of 400 was 20, the square root of 900 is 30, and it's in between. If I looked at 625 without the decimal, that would be in between these. It's an odd number, ends in 5, and so since it's got a decimal in there, we have to move that decimal point over, and it would end up being 2.5 meters. But they want the nearest whole unit, so in this case, I would just say 3 meters. On the last type of problem, they're going to ask for subsets of real numbers. So the real number system is divided into two different types. We've got rational numbers, which has the word ratio in there, which is a comparison of two numbers, which is basically a fraction. Or irrational numbers. Irrational numbers just mean not fractions. And so not fractions, numbers that you will not see as fractions, are going to be pi is a common one you'll see, and these right here. This is not a perfect square. And so ones that you've seen as not a perfect square, pi, are going to end up being irrational. Everything else will be rational, numbers that we can write as fractions. Underneath rational, though, we have different types. We've got integers, whole, and natural. Natural numbers are just counting numbers. Whole includes all the counting numbers, but 0 as well. Integers are positive and negatives. So this one here is everything. We've got rational, we've got integer, and we have whole, and we have natural. And on this one, it's not a perfect square, so this would be irrational. And this one is a fraction, but not an integer, so it's just a rational number. Not a perfect square here again, so we have an irrational number. So those are the types of problems you're going to see on today's homework. Good luck.